Hello, welcome back. We're going to start a new unit today. We're going to be focusing mostly on lines and transversals and how that applies to angles. Okay, so this is the start of unit 3. Okay, we're going to be right here on slide number 3. This is where we're going to start. And this is with lines and transversals. Okay, here's the PowerPoint that we're going to be scrolling through. Okay, so we got lines, transversals. We're also going to talk about angles formed by transversals, and we're going to take this information, the angles formed by transversals, and in the next video, we're going to come up with different angle pairs that we can find missing measures for. Okay, so that's where we're heading in this unit. Let's go ahead and take a look at this do now. Okay, our goal here is to find the missing variable for each one of these. And I recognize that this picture is not on your do now, but what you need to do is you need to just write down the work of what I'm about to show you here. Okay, so I'm going to come here to our annotations. Okay, the first thing that we need to do is to identify the kind of relationship that these two angles have. Okay, so what kind of relationship do they have? Okay, so that's going to be the same thing that we do for every single problem in this unit. Okay, what kind of relationship do the angles have? So after we figure out what kind of relationship the angles have, okay, the second thing that we're going to do is we are going to set up an equation that represents the relationship. Okay, so after we set up our equation that represents the relationship, then our final step is to find the variable that we're looking for. So we're going to solve that equation. Sometimes some of the questions that you're going to be asked is to find the missing angle measure, right? So sometimes you might have to solve for x, and then you have to take x and plug it back in to find the specific angle. So just because you find out what the variable is, okay, that doesn't mean that you're done with the problem. You need to check and make sure that you actually answered the question that was being asked. So in this case, we're just finding the two variables. Okay, so this picture right here, what we have with this picture is, of course, a linear pair. Okay, so we have a linear pair. Remember, with linear pairs, okay, what we're looking for is this word right here. We're looking for two angles that make a line. So when I add the 4x plus 20, this red piece here, when I add this with the x minus 10, okay, that gives me this straight line, right? So that's what we're looking for with the linear pair. Okay, you can think of it as adding or just combining the two angles together. So linear pair makes a straight line. So what we need to do is we need to set up our equation to where it matches the definition of linear pair. Okay, so we know that a line is 180 degrees. So when I combine these two angles together, they should equal 180 degrees. So our equation looks like this: 4x plus 20 plus x minus 10 equals 180. Okay, from this point, we're just solving an equation. So what I do to one side, I have to do to both sides, except when I'm combining the like terms on one side. So what I'm going to do first is I'm going to simplify the left, and I'm going to simplify the right. And after I do that, then I'm going to do my properties of equalities to manipulate the equation to get x by itself. Okay, so I've underlined here in black all of the x terms. So we have 4x plus x, which gives us 5x. Okay, now I'm going to take the same idea and with the numbers, okay, I'm going to circle the numbers. Okay, circle in the numbers here. Okay, and I'm going to combine the two numbers together. So I have a positive 20 and a negative 10. When I combine them together, that gives me a positive 10. Okay, and then on the left or the right side, okay, there's only the 180. So the 180 just remains by itself. 5x plus 10 equals 180. Okay, I have to get, remember this x, I'm trying to find x. So I'm going to get rid of everything that's not the x. So I subtract 10 because that is the opposite operation. And I do it to both sides. And what I'm left with is 5x equals, and this is going to be 170. Okay, almost done here. I need to divide by 5 because this 5 is multiplying to the x. So to get rid of the 5, I divide by 5 on both sides. And it doesn't turn into a 0, it just turns into a positive 1. 5 divided by 5 is 1. Okay, so when I do this, I get 1x is equal to 170 divided by 5, which gives me a 3. And then that's 15. I have 20 left over. And a 4, 34. Okay, so there's our first example. Okay, the second one over here, okay, notice that the two angles are across from each other. Okay, so this one is going to be a vertical pair. Anytime that you see a big X like this, okay, it's going to be a vertical pair. We know that vertical pairs are congruent. They're the same angle measure. Okay, so for this specific problem, if they're the same, I can set them equal to each other. The 9y plus 7 is going to be equal to the 2y plus 98. Okay, so we know they're the same angle measure. I've got this top angle, which is equal to the bottom angle. Now from here, we're just solving for y, just like we did down here in this last example. Okay, so I need to get all the y's to one side, all the numbers to the other. And the easiest way to do this is going to be to get the y's on the left, the numbers on the right, because I have more y's on the left side than I do the right. So to do this, I'm going to subtract 2y. Don't subtract just 2, I have to subtract 2y. And do that to both sides. 9 minus 2 gives me 7. So I have 7y on the left. Still on the left. Okay, this guy comes straight down. So does the 98. 7y plus 7 equals 98. Okay, now I'm done with the y's. Okay, now I have to get rid of the 7. So I want to do the opposite operation here. And the opposite of add is subtract. So I subtract 7 on both sides. The 7y comes down. And I end up with 7y equals 91. The last step for this problem, get rid of the 7, so that way we get 1y by itself. So I divide by 7 on both sides. We end up with y is equal to 13. Okay, so as you can tell, okay, this unit, I mean, it's important that we understand our relationships of the angles, right? That's the geometry piece. But again, just like I've talked about plenty of times before, most of the work that we're going to be doing is going to be solving equations, okay? Solving equations is going to be the most important thing that you know how to do in this class. Okay, so this takes care of our first example here. So that's going to go into these two boxes. Okay, now for transversal, okay, we need to define what a transversal is. Okay, here's your definition. A transversal is a line that intersects two or more lines at different points. Okay, so in this specific example here, this purple line is the transversal to the two blue lines. Okay, so that's going to go right here underneath transversal. Underneath other notes, okay, something that you might need to know is what a concurrent line is. Okay, a concurrent line is when three or more lines intersect at the same point. Okay, so when they intersect at the same point, that's called concurrent lines. We're going to focus more on transversals than concurrents in this unit though. Okay, so let's go ahead and start talking about what kind of angles can be formed from transversals. Okay, so the first set of angles that we have, we call corresponding angles. Corresponding angles. Now these angles are located in the same position. Same position when the transversal intersects the lines. Okay, so for each transversal, so like this example right here, this purple line, the transversal intersects two lines. Okay, so for each set of transversals, okay, there's always going to be four sets of corresponding angles. Okay, so we had these two blue stars. Okay, both of the blue stars, okay, I like to label the angles in terms of top, bottom, left, and right. Okay, so these stars, if you're only looking at this top piece up here, okay, so again, if you're only looking up here at these four angles, okay, this blue star is in the top because it's on top of this blue line. It's in the top and right position. It's to the right of the transversal. Okay, so this is going to be the top right. Now notice if I only look at these four angles down here, this blue star is also in the top right position. Okay, I'm not focusing on this first set that we just took a look at. I'm only focusing on these four down here. Okay, so this blue star is on top of this blue line, and it is also to the right of the purple. Okay, so we're going to label this as the top right. So the blue stars are in the same position. Same position just means that they're both either top right, top left, bottom right, or bottom left. Okay, now we have these two hearts. Okay, the two hearts. If I cover up this piece right here, or this entire thing down here, whoops, I don't want that yet. So if I cover up all of this down here, okay, this purple or the pink heart right here is going to be in the top because it's on top of this blue line, and it's going to be left. So we have top left I come down here to this pink heart. It is also on top of this blue line and left of the purple transversal. So the pink heart is top left. I'll do pink for this one. Top left. Okay, next up we have two smiley faces. The smiley faces are in the same position because they are both on the bottom of the blue lines and they're both to the left of the purple line. So for the blue smileys, we have, can't really see that yellow. Let me change it. We have the bottom left, bottom left. Okay, and the orange triangles, okay, they're both on the bottom side of the blue lines and they're on the right side of the purple. So those are also corresponding. Okay, so anytime that you're doing these pairs, okay, the first thing that you need to do is identify where the angle is that they're asking you about. Right? Is it in the top left? Is it in the bottom left? Is it top right or is it bottom right? Because once you do this, okay, it helps because you understand your definitions. So corresponding angles, we're looking for the same position. That's why I underlined this. The same position out of the top left, top right, bottom left, bottom right. All right, now when we go to alternate interior angles, okay, these are different than corresponding because now what we're looking at angles that are on the opposite. Okay, so I'm underlining opposite and sides, okay, opposite sides, and they're both in between the other two lines. So there are two things that we're looking for here. We're looking opposite sides of the transversal, and we're looking in between the other two lines. Okay, the way that I like to think about alternate interior is when you make a sandwich, okay, you have two pieces of bread. So here we have our two blue lines, our pieces of bread, okay, and anything that's in between are the toppings for the sandwich. Okay, so in between we have our toppings. That is for alternate interior angles. They're in between the sandwich bread. Okay, let's take a look at a few examples here. Okay, notice the blue stars. Okay, our blue stars are both in between. They're in between the blue lines, so they're inside our sandwich, but they're on opposite sides of the purple line. Okay, that's what the word alternate means. Okay, alternate means opposite. For those of you that like sports, okay, you have all sorts of jerseys. You have your home jersey, you have your away jerseys, you have your alternate jerseys. And alternate jerseys are usually the opposite of the home jerseys, right? So for those of you that like the Texas Rangers, okay, the Rangers typically wear, I think this year they wore blue jerseys and red jerseys, right? And then an alternate for them would have been white jerseys. Okay, each year it's different. Sometimes it's hard to keep up with. Okay, you could think of like Memorial Day. Okay, Memorial Day, Most Major League Baseball teams, they wear camo jerseys. Okay, so those are all alternate jerseys. They're opposite of what you would normally wear. Okay, the interior is just inside. Okay, so we have opposite angles that are on the inside. Opposite angles that are on the inside. They're opposite of the transversal. Okay, the only other set that we have here are the two pink hearts. Okay, the pink hearts, again, are opposite of each other from the purple line, but they are sandwiched in between the blue lines. Okay, now remember we had in the last slide we had top right, we had top left, bottom left, and bottom right. Top left, bottom left, bottom right, and top right. So if I took the opposite of top, that's going to be on the bottom. If I take the opposite of left, that's going to be on the right. Okay, so if I'm looking at the blue star, okay, this one right here that I just underlined, here I'll circle it. Okay, this one is in the bottom left position. What is opposite of bottom left? Well, opposite of bottom is top, so it should be somewhere on the top, and it should be on the right side. Okay, you can do the same thing with the pink heart. That's another way for you to think about it. Okay, next up, we have, just making sure I didn't skip something, we have consecutive interior angles. Sometimes these get referred to as the same side interior angles. So if you see consecutive interior angles, it's the same thing as same side interior angles. So again, with these, just like with the alternate interior angles, they're both going to be on the inside. Okay, they're both going to be on the inside. Okay, but these are going to be on the same side of the transversal. Okay, so a little bit different here. So let's go ahead and take a look at an example. Okay, here's our blue stars. Okay, same side of the transversal. Here's our transversal. It's in purple, transversal, because it intersects the two blue lines, right? That's what transversal means. So the purple is the transversal. I like using same side interior instead of consecutive interior because same side helps remind me that the angles have to be located on the same side of the transversal. Okay. So here's my two blue stars. They're both on the same side of the transversal, which is the purple, and they're both on the inside of the sandwich. Okay, same thing with the two pink hearts. This time the pink hearts are on the left side of the transversal, but they're both inside of our sandwich that we have created. Okay, here is our last kind of relationship that we have, alternate exterior angles. Alternate exterior angles. Okay, similar to the alternate interior, except this time we have exterior, which is on the outside. Okay, so we're still going to be on the opposite side of the transversal. Okay, but instead of us being located inside the sandwich, we're going to be on the outside of the sandwich. Okay. Again, with these, there's only going to be two sets of alternate exterior angles. Okay, so here are the two examples. I've got blue star. Okay, this blue star is on the top of this transversal up here. And that's what we need. It needs to be on top of the sandwich. Okay, typically on the top of our sandwiches, we don't put anything except for just our piece of bread. I guess you could put chips on the top of the sandwich. Okay, but you can think of it as, okay, the top, I've got nothing. I have just the star on the top. Okay, that could be my chips. I put chips on top of my sandwich. And then on the bottom, I've got my plate. Okay, so we have chips on top and plate on the bottom. And they have to be on the opposite side of this transversal here. Okay, so the blue star satisfies this condition. So does the pink heart. Okay, that takes care of alternate exterior angles. Okay, in terms of other things that we need to know, you still have your linear pairs, you still have your vertical pairs. Okay, so those are still in play. Okay, but with this activity, what we're going to do is we're going to identify each of the following pairs that are over here on the left-hand side. Okay, so we're going to start off with angle 1 and angle 8. Angle 1 and 8. So here's 1. And here's 8. Okay, this one's actually pretty easy because we just saw an example of this in the last slide. Okay, so this one is alternate exterior angles. Okay, because the 1 and the 8 are on the outside of the sandwich and they're on the opposite sides of the transversal. Okay, angles 4 and 6. Okay, here's 4. And here's 6. 4 and 6, these are on the same side of the transversal and they're in between our sandwich. Okay, so these are going to be same side interior. I'll do one more. Angle 1 and angle 6. Angle 1 and angle 6. So here's angle 1. I'm going to do angle 1 in green. Angle 1 and angle 6. Okay, so angle 1 and 6. Notice that they're on opposite sides of the transversal. Okay, so we could say alternate just because they're on opposite sides. Okay, but we don't have any kind of term that gives us one angle that's on the outside of our other two lines and one that's on the inside. Okay, so for this one, okay, this one's actually going to be none because we can't identify it with one of the 4 terms that we used in the previous slides. Okay, so there's a few examples. What we're going to do here on this slide is we're going to use just our basic, our first two pairs to figure out what all the missing angle measures are for this picture. Okay, and a little side note is that quadrilaterals add up to 360 degrees. Okay, so let's go ahead and start taking a look at these. Okay, remember, vertical is congruent and linear pair adds to 180. All right, I'm just going to start here with 110 degrees. Okay, this 110 degrees, okay, the easiest one to paired up with is going to be across from it. So this angle right here is also going to be 110 degrees. Okay, if you wanted to, you could go through and you could fill in all of the other vertical pairs. Okay, so like this 115, what's across from it is this guy. Okay, so this one's going to be 115 degrees. I can do the same thing with 75 down here at the bottom. Okay, so sometimes it just helps to fill in the things that you already know or the easiest things first. All right, so here's 75 degrees. Okay, that's all that we know about this picture so far. So we've taken care of the verticals. Okay, now let's move on to linear pairs. Okay, so linear pairs, if I'm going to do this angle in green right here, or if I wanted to do this one on the bottom, okay, they're both the same, right, because they're across from each other. Okay, to figure out this angle in green, what I need to do is I need to set up an equation that adds up to 180 degrees. So the green, we're just going to call it x, plus 110 degrees equals 180. Subtract 110 on both sides. Real easy, real simple. X is 70. Okay, so we can fill that in right there and right here. Okay, then I would move on to the next one. Okay, so let's come down here to the 75s. Okay, if I wanted to figure out this purple angle, or maroon, what I would do for this is I would say, we're going to call this y. I'm going to say y plus 75 equals 180. Subtract 75 on both sides. You get y equals 105 degrees. So we have that there. We have it here on the outside. Boom. Okay, I'd come over here and do the reds next. Okay, so reds, so the linear pairs with the reds, I mean. Okay, so I'm going to do these angles in blue. To figure out a blue angle, I'm going to call this Z. Z plus 115 equals 180. Subtract 115 from both sides. And Z is equal to 65 degrees. Okay, now at this point you're stuck. You've taken care of the vertical pairs, you've taken care of the linear pairs. Okay, so you have to go to some things that you have learned previously. Okay, and one of those things is about triangles. We all know that triangles, they add up to 180 degrees. So if I were to find this pink angle, what I would do is I would come over here and I would say 70 plus 65 plus, we're going to call this A, is going to be equal to 180 degrees. Okay, and then from that point, we get 135, because that's what these two combine to, plus A equals 180. Subtract 135 from both sides, and A is 45 degrees. Okay, so we get 45 degrees here. We get 45 degrees here because they're vertical pairs. Okay, and that's the last one that I'm going to do for this problem right here. You can go on now and you can figure out these two in brown by using the linear pairs with the 45 degrees. And then once you have this guy, okay, you're going to figure out this angle. We're going to call this one B. Okay, you can figure out B from our little bullet point up here at the top right. Quadrilaterals add up to 360 degrees. So you're going to add these four angles, set them equal to 360. That'll give you B. That gives you this one, and then you use your linear pairs to finish it off. So lots of things going on here in this unit. Okay, lots of things going on here. Let me get rid of this real quick. Okay, so make sure that you fill in your definitions. Here's your examples. All these have text boxes that go with them. Okay, but what you're going to see is we're going to start doing a lot of figuring out angle pairs, and then figuring out, figuring out what the missing angle measures are. So we're going to have pictures like this down here at the bottom. And that's going to be really similar to what we just did up here at the top, except we're going to have more relationships to help us find some of these missing angles a little bit faster. Okay, so that's the whole objective of this unit, to identify angle relationships and then fill in missing angles of a picture. If you have questions, leave them in the Google Classroom or send an email. In any case, what we're going to take a look at in the next video are parallel lines and transversals and what we can determine from those two things.